Everyone, welcome to this webinar this morning. Today we're going to have a look at the boost quality and how we can optimize machine performance and data reuse within Autodesk Inventor. I'm Gideon Besaidnout and I'm an application engineer for micrographics. When it comes to this topic, there's quite a lot that we can go through and discuss. So there's certain key points and key factors that I thought will be quite important when we look at this topic, and we're going to have a look at how we can utilize some of these tools. On today's agenda, we've got an introduction. We're going to look at the importance of quality and throughput in manufacturing, enhancing manufacturing quality, standardization for consistency, optimizing machine capability, reuse existing data for faster production, and lastly we're going to have a closing and a summary. On the introduction, the streamlined workflow, increase productivity, enhance product quality, boosted quality, and optimize machine performance with efficient data reuse. Now, in today's competitive manufacturing environment, Autodesk Inventor empowers engineers to streamline workflows where we can increase productivity, enhance product quality, and this is all done by leveraging powerful tools within Inventor. Boosted quality through consistent design standards, integrated simulation tools, for instance like tolerance analysis. And tolerance analysis, it is an add-on for Autodesk Inventor where we can ensure reliable, high-performance products from concepts to production. We're going to have a look at the optimized machine performance by validating mechanical systems with motion studies, interference checks, performance simulations, where the most focus is going to be on the reducing costly errors and downtime. Efficient data reuse. When we think about the efficient data reuse, there's quite a lot of ways we can reuse data within Autodesk Inventor. Some of these features include iParts, iAssemblies, and design copy tools. And this allows for the different teams to repurpose existing models and designs. This also accelerates development while maintaining accuracy and consistency. Together, these capabilities support faster design cycles. It reduces rework, smarter engineering, and the most important, the driving of innovation for manufacturing excellence within Autodesk Inventor. The importance of quality and throughput in manufacturing. When we think about modern manufacturing, quality and throughput are two of the most critical performance indicators. Striking the right balance between them is really essential for delivering that high value products and meeting customer requirements or demands while maintaining profitability. As we can see, I've just created like a small graph, and here we can see where we look at the key factors. The maintaining of profitability, where we got our goals, the expected, and where we currently actually are. We've got our customer demands, the high value products, and the critical performance indicators. That's quite important in any part of quality within a company, within software, and so on. Ensuring product quality within Inventor. Now, some of the key factors, it is the tolerance analysis, simulation and stress analysis, and interference checks. Quality refers to the degree to which a product or process meets defined requirements and expectations. Inventor does help teams embed quality directly into the design process by providing tools to reduce errors, improve consistency, and validate designs before they reach the shop floor. When it comes to ensuring product quality, there's quite a big variety that you can do within Inventor, from your version control to your iProperties, where you can go set up all your different types of project numbers, drawing numbers, who was the engineer that checked it, or who's going to be the engineer that's going to check your drawings, and so on. And some of these tools that is quite important would be the tolerance analysis, the simulation, and the interference check. The tolerance analysis in Autodesk Inventor is really a critical part of design validation in manufacturing. It ensures that even when manufacturing variations, that all the parts will fit and function properly when they are assembled. Now, this simplifies and enhances the process through powerful built-in and integration tools. Like I mentioned, the tolerance analysis, it is an add-on when it comes to Inventor Professional. Now, why does the tolerance analysis matter? When we think about the manufacturing process, we all know that it's never perfect. We've got variations in materials, tooling, assembly lead to small dimensional differences. And that is even for, if we think about the limits and fits. You've got a minimum and maximum tolerance, for instance, your shaft, and a minimum and maximum tolerance within your gear. Now, if your shaft is on its minimum tolerance and your gear is on your minimum tolerance, the limit and fit, it's going to be out of specification. So you're going to have that play on the inside for your driving shaft to drive the gear. There's going to be a little bit of a gap. So some of the important things why it matters is the assembly failures. Like I mentioned, when it comes to assembly failures, it can be parts that won't fit because of your minimum and maximum tolerances. Poor product performance, where we can also look at interference checks. Poor product performance, another one would be where we're going to look at increased scrap and rework. And lastly, all these errors can lead to customer dissatisfaction, as you can miss your deadlines. With your limits fits, you might scrap your items because the tolerance on the inside would not work. One of the very important things about the tolerance analysis, it helps mitigate these risks by evaluating how variations accumulate across multiple components. And as a designer, when you use the tolerance analysis, especially when you think about limits and fits, you can always work in conjunction with your production, with your workshop, and they can go and adjust some of the tolerances to ensure that everything works in the manner that it should. When you've got your interference checks, or even in your product performance, it can go and work hand in hand. The benefits of performing tolerance analysis: you've got your improved quality, it reduces the cost, faster prototyping, and better communication between all the different departments. When we think about the improved quality, this ensures that your parts fit correctly the first time, reduce cost, it minimizes over-tolerancing that can increase machining or inspecting costs. And that is one of the key factors that I also spoke about when it comes to the better communication within all the relevant departments. We've got faster prototyping, where you can catch design issues early without relying on physical prototypes. Better communication, where you clearly communicate tolerance intent to the manufacturing teams using all your 3D annotations and your drawings. Now that is also quite important, as you have to go and have a look and see how all of these do combine. Now, some of the key takeaways when it comes to the tolerance analysis in Autodesk Inventor, it allows the engineers to design with confidence and ensuring that the parts not only meet the specifications individually, but also perform reliable as part of the complete assembly. Now, this will reduce your risk, waste, and cost throughout the product lifecycle. Simulation and stress analysis in Autodesk Inventor. Now, that is essential tools in the engineering design process because it enables, for instance, teams to test and validate your products virtually before committing to the physical prototype. Inventor already includes powerful simulation features that allow users to access product performance under real-world conditions directly within design environments. The key capabilities in Inventor, it is your stress analysis environment. Now this can perform, for instance, static stress analysis on your parts or assembly, where you go and apply your force, your pressure, your constraints, and loads to see how the model deforms. You also will get a visual result such as your stress distribution or your strain, even displacement, and you can go set your different safety factors. You do have frame and beam analysis. This is ideal for structural frames that is made from standard profiles. You can calculate your bending moments, shear forces, and deflections in a lightweight solver. Model analysis, for instance, your dynamic behavior, and this will determine natural frequencies of your component. It can also identify potential vibration issues easily in the design. Contact and assembly analysis. This will simulate how multiple parts interact under load. You can define your contact sets to evaluate realistic movement and stress. Now here it just shows you a small picture of a new simulation that can be performed within Autodesk Inventor. Why would we use simulation in Inventor? It reduces prototyping and cost, where you can spot issues digitally before physical testing. Shorten development time, where you avoid redesign cycles by validating them early. Improve product quality. This ensures performance and reliability under real-world loads. Optimize material usage, where you can minimize weight while maintaining safety and strength. Now, some of the typical applications where we can utilize some of these different types of calculations or even simulations within Inventor is, for instance, where we want to validate a bracket strength under a specific load. We can test housing deformation for electronic enclosures, analyze the gear or shaft deflection, and evaluate frame structures for building or machinery. And you can even take this further and go into Inventor Nastran, where it even has a lot more capability than the standard Inventor Professional. And Nastran, it is also an application especially for FEA analysis. Now, some of the key takeaways when it comes to the simulation, it is that simulation and stress analysis tools, they do empower engineers to design smarter by making performance-driven choices before fabrication begins. This also leads to more efficient, safer, and cost-effective products. Interference check in Autodesk Inventor. Now, this is a vital step in verifying the parts in an assembly to ensure that they fit together correctly without overlapping in physical space. Inventor provides built-in tools to automatically detect these issues, helping engineers prevent assembly errors and costly rework. Now, what is an interference check? An interference check analyzes two or more components within an assembly to see if their volume intersects. Overlapping geometry indicates a design flow, such as components occupying the same space, which would lead to manufacturing or assembly issues. The key features within Inventor would be the automatic interference detection. Now, this quickly scans the entire assembly or selected components. It also highlights areas where the parts intersect, so you do get a physical display where you can see the volume of interference. And this also allows you to go make your modifications in your assembly before you go and produce your manufacturing drawings. Your live feedback during an assembly. While inserting or constraining parts, Inventor provides real-time visual cues if components clash. This prevents errors before constraints are finalized. Your interference report. Inventor also generates a small summary report that details all your detected interference, and this can be saved and shared for design reviews. So you will be able to go and send this, for instance, to your engineer. Your integration with design review. You can also use Autodesk Vault and share design views to collaborate across teams, where you can flag issues early in the process. Now, why does this matter? We can avoid assembly errors to ensure that parts will fit correctly the first time, save time and cost where we can detect and resolve issues before prototyping or even before manufacturing, improve communication, where you can actually go and share your clash reports with the manufacturing and quality teams, increase product reliability to ensure functional movement and clearance in dynamic assemblies. Some of the typical use cases would be, for instance, to check for fits between fasteners and holes. You can also validate clearance in gear assemblies, ensure electronic components don't collide, for instance, with the housing. You can review packaging or enclosure designs. And the key takeaway would be that Inventor's interference check tools allows engineers to catch critical design issues early, where you can save time, reduce waste, and ensure reliable assemblies. Improving throughput with Inventor. Now, throughput relies on efficient, repeatable, and scalable design workflows. Inventor speeds up development while maintaining design integrity. We're going to have a look at some of the key features. Now, iParts and iAssemblies quickly generate design variations for products and families, and you can also use iParts and iAssemblies for reuse. Your design reuse tools, where you can go and also utilize derived components and use design assistants to repurpose existing data. And within iParts and iAssemblies, you can also do model states. Then you do have your design reuse tools. And lastly, automation with iLogic, where you can automate repetitive tasks and configure custom models in a second. When we look at the big picture or the outcome, you've got faster time to market, consistent product iterations, and optimized handoff to production. So you are really saving quite a lot of time. And this will all be within your standardization tools and the outcome. Just some extra information regarding iParts and iAssemblies in Inventor. In today's manufacturing environment, product customization and design reuse are essential for saving time and improving consistency. iParts and iAssembly tools enable engineers to efficiently manage families, for parts, and configuration. This boosts productivity while maintaining control over design variations. iParts are part files that contain multiple variations of a single design. It's similar to a product catalog where you can go and create your single part and use that single part and set up a specific catalog. One thing about iParts, it needs to be similar in shape, but it can have size variations, as you can see. Now this would be a small example of just a block where you've got a length, height, and thickness, and you would draw your one block, and then you can go and create an iPart with different types of variations. Now some of the used cases is this can be for bolts, shafts, couplings, plates with varying dimensions or features, even sheet metal parts with different bendy radius or hole patterns, but it's not limited to those use cases. This is just a small example of what you can utilize this for. The key features would be the master part with variable parameters, where it stores all the variations into a single table, and you can go and generate your individual parts files directly from this table. When we think about the key features, you go and create a master part with a variable parameter, for instance length, diameter, hole spacing, etc. You store all your variations in a single table and automatically generate individual part files as needed. One of the big benefits is you eliminate the need to model each variant manually, so you're already saving time and it's consistent. You can also edit the table via Excel spreadsheet, so you can drive your whole part. Now it's important that when you go and create an iAssembly, you will have to create your iParts, so that you do have your different variation of the part to utilize your different variations of the assembly. Now iAssemblies is to extend the same concept as an assembly, They allow you to define and manage multiple configurations of a full assembly layout, where you can have different variations of the assembly. One of the examples would be if you have a vise, you can go and create an eye assembly and have different lengths and different widths of that vise, as an example. More use cases is machines or enclosures with optimal components and assemblies with different component sizes or even positions. The key features is where we can define varying components, constraints, or patterns per configuration. You can easily switch between assembly states, even link to the BOM and drawing views for each variant. You can simplify management of configurable products and support modular design approaches. Now, how they improve your workflow. We do have design reuse, where we quickly create new variations from new or existing designs. Consistency, that maintains design intent across all versions. Faster BOM generation, automate part list for each configuration. Improved collaboration, where you can share the master file while minimizing file sprawl. And the key takeaway when it comes to iParts and iAssembly, it allows engineers to efficiently manage product families, reduce manual modeling effort, and maintain quality across variations. This empowers the teams to deliver customized solutions at scale. Model states is also a very powerful feature within Autodesk Inventor, and this allows users to create and manage multiple variations of a part or assembly within a single file. Whether you're working with your different manufacturing stages or configurations, even simplified representations, model states streamline your design process and reduce file clutter. Now, what is a model state? A model state enables you to define and store dimensional variations, examples, different lengths or hole patterns, feature suppression, where you can turn off, as an example, fillets or holes, component suppression, or even replacement in an assembly, different materials or properties, manufacturing stages, example, raw, machine, or final machine stages. Think of it as a smart design table that lives inside your part or assembly file. Now, some of the use cases for model states, we can think about the manufacturing process stage, where you can show castings, forgings, machining, and even finished states of your part. Configurable product variations, where model different sizes, features, or options, for instance, a product family. Simplified representations, for instance, creating a lightweight version of the assembly for documentation or even simulation. Your BOM management, where you can define your separate bill of materials entries for each model state. Drawing automation, where you can link drawing views to specific model states for accurate documentation. Some of the differences from iParts, iAssemblies, and model states. If we look at the feature, for instance, the file structure, the iParts and iAssembly creates multiple files, but model states it stays within a single file. Your workflow use cases, iParts and iAssemblies, you've got your large product families, and in the model stage, you've got your design stages or limited variations. Your BOM entries, you've got your multiple file entries or your multiple states in a single file. The management, it requires design assistant for copying if you think about iParts and iAssemblies. And model states, it's easy switching inside Inventor as it stays within a single file. Some of the benefits of using model states. You've got your simplified file management. This means it centralizes and organizes your storage and reduces complexity and improve your team collaboration. You've got your improved performance, faster load times, and smoother navigational through optimized file structures. Your flexible documentation, it's easier creation, updating and sharing of your design documentation. Design efficiency, where it streamlines the process and reuse components. This will speed up your design process and reduce rework. Key design reuse tools in Inventor. Like I mentioned earlier, iParts and iAssemblies can be used for reuse in Inventor. You've got your Derive tool, your design copy with iLogic, even templates and content center, and your design assistant. Design reuse, it is a key strategy for improving productivity, also to reduce errors and accelerate product development. Now there's quite a few different tools that enables engineers to repurpose existing models and templates and logic to create new designs. Now the key design reuse tools for Inventor, like your iParts and iAssemblies, you can create configurable families of parts and assemblies. You manage variations, and it's ideal for modular or customizable product lines. One of the biggest benefits would be rapidly generate multiple versions of a component with a shared design intent. You've got your Derive tool, where you can import geometry, parameters, or even bodies from one part into another. You maintain a live link to the source model for downstream updates. It's great for designing components that evolve from a master model. Because if your base model updates your master, if that updates and you have used your Derive, you do have the function for your new part also to update regarding that part that was used. And if your new model actually updates, it doesn't affect your master. So that is quite a good benefit. Your design copy with iLogic. Now this automates the duplication of parts and assemblies with unique properties. You can also use rule-based automation to rename, use your parameters, or even adjust features. It's ideal for creating one-off versions for standard components. You can save your time by creating custom models from existing templates with minimal manual editing. Your design assistant. Now usually when you go and install Autodesk Inventor, it does install Design Assistant, and you can just go search in your search bar Design Assistant. You can also open Design Assistant within Inventor, but you do have more functionality outside Inventor if you go and open it from your search bar. Now this is a standalone tool for copying and renaming assemblies or files while preserving references and links. It manages the dependencies and avoid duplication errors. It's useful for controlled reuse of large or interlinked assemblies. One of the benefits would be to safely reuse large data sets across multiple projects or customers. Templates and Content Center. You can use your custom parts, assemblies, and join templates with preset standards. You can access standard parts and fasteners from the Content Center library. You start with a predefined, company-approved asset to maintain consistency. Now, why design reuse matters. You've got your faster development, where you focus on innovation instead of repeating work. Greater consistency, where you reduce variation and ensure compliance with standards. Error reduction, reuse, validate designs instead of recreating them. Improved collaboration, where you share your assets and logic within your team. The design reuse tools empower engineers or designers to work smarter, not harder, enabling faster, more consistent design workflows by leveraging what's already been built and proven. We're just going to have a look quickly at the derived tool and what is the derived. The derived tool allows you to derive components that's built upon an existing model by using it as a base. The key design features are copied from the base components into the new one, ensuring consistency and maintaining design intent. This transformed information helps define the geometry of the derived component. It allows for easily and efficient modification and seamless integration with the overall design. As you can see, here are some of the key features for using a derived. You can reuse geometry. So you extract and reuse, for instance, faces, edges, features, or sketches. You can also bring in your parameters that was created in that part. Associativity, derived parts maintain a link to the original file, updating automatically when the source change, when your base change. Feature control, you can choose to import the entire model or only specific features for streamlined parts. Simplification, you create lightweight or simplified versions by excluding unnecessary details for faster performance. Like I mentioned, parameter sharing, you pass parameters and constraints from the original part to the derived part to maintain the design intent. iLogic Design Copy. Now, what is iLogic Design Copy? This is an automation tool within Autodesk Inventor that helps you quickly create multiple variations of a design by copying and modifying it. And you'll find this iLogic Design Copy on your Home tab in Inventor when you open it up. You've got your automated design duplication, where you actually go and create copies of parts, assemblies, or drawings without manual file duplication. Consistent naming and management, it automatically renames your files and updates references to avoid conflicts. It speeds up product variations. It's ideal for creating families of products or multiple configurations quickly and error-free. As you can see, here's an example of an iLogic Design Copy where you can go choose the project you're going to copy it from. You can choose your drawings, parts, non-Inventor files, assemblies, and then you can go copy it into a new product or project. The Design Assistant, it is a powerful file management and automation tool that's included with Autodesk Inventor. It helps organize, update, and maintain your Inventor files with their relationships. You've got your batch rename and replace. This will rename your files or replace references across multiple files simultaneously. Manage file reference. It is easily updated or repair broken links between parts, assemblies, and drawings. Your automation tasks. This also performs repetitive actions like copying, deleting, or even moving your files with your preset rules. You've got check file dependencies where you can view and analyze the relationship between design files to ensure consistency. Simplify data management streamlines the process of preparing designs for revisions or reuse. And here you do have quite a nice example on how the design assistant works. The key standardization tools in Inventor. If we think about standardization in a design, this ensures your consistency, improves collaboration, it reduces errors, and supports scalable engineering practices. Now, Inventor does offer a suite of tools to help teams enforce and maintain design standards across projects and teams. And one of them would be your iLogic rule-based automation. It automates design process with conditional logic and parameters. Templates. It standardizes your parts, assemblies, and drawing creation for consistency. Content Center, where you can access a library of standard components for reuse. Your design data folder. It stores and manages your shared styles, materials, and standards if you have created your own materials or styles and so on. And it all integrates with Autodesk Vault. And Vault does manage data, revisions, or versions, and collaboration through securely version control. Now, Vault Basic does have version control, and Vault Professional does have revision control and lifecycle management. We're just going to have a quick look at the automation with iLogic in Autodesk Inventor. iLogic is a scripting environmental tool that allows users to embed rules, conditions directly into your parts, assemblies, or drawings. You automate repetitive tasks. You can create custom or user-driven configuration interfaces. It enforces design standards and logic. Unlike traditional programming, iLogic is designed for engineers, offering a simplified syntax and integration with Inventor's parameters and features. The key capabilities of iLogic is your parameter-based automation, where you can drive features and dimensions using conditional logic, automatically update part size, patterns, or positions based on user input. Some of the examples would be to change the number of holes in a plate when length exceeds a certain value. Your configurable assemblies. This controls component visibility, suppression, or even substitution. You can drive your bombs and variations dynamically. Example, you can swap a motor or fastener based on power rating or application type. Your file management and naming rules, auto rename parts and assemblies based on project codes. You save files to specific folders or based on your user selection. You can save configuration with a part number and date stamp. You've got your custom forms and interface. You create input forms for designers or sales teams to generate models without CAD knowledge. An example would be, for instance, a salesperson enters dimensions and features via a form, and a custom model is generated instantly. The benefits of iLogic automation: you've got your faster design cycles. This reduces manual effort and turnaround time. Consistency and accuracy eliminates the input errors and standardized outputs. Customized solutions at scale, where you can generate product variations effortlessly. Enhanced productivity. It frees engineers to focus on innovation rather than repetition. Some of the common uses, if we think about common use cases, would be, for instance, automating product configurations. Smart parts, for instance, tooling, enclosures, and jigs. Custom drawing views and annotation. And manufacturing prep time. The key takeaways with iLogic is Autodesk Inventor becomes more than just a CAD tool. It is transformed into a design automation platform, enabling companies to deliver high-quality, customized solutions faster and more efficiently. Why standardization matters? Because we look at improving design consistency. It does accelerate training because you save so much time. It boosts efficiency and ensures compliance. Outcome: smarter, faster, and higher quality manufacturing with Autodesk Inventor. By leveraging the full capabilities of the software, engineering teams can achieve measurable improvements across their design and manufacturing workflow. You improve product quality, increase efficiency and throughput, better engineering decisions, reduce cost and waste, and stronger collaboration. Another handy tool within Inventor would be your shape generator. This really does assist with reducing material waste through optimization with Autodesk Inventor. The purpose is you can create lightweight, optimized models based on design requirements. You've got your initial step where you begin with an approximate based model representing the desired volume or shape. You set your constraints. This will define design criteria such as load, supports, and material. Generate a mesh. You run the shape generator to produce a 3D mesh based on the input of constraints. Refinement. Use the mesh as a guide to transition into the part modeling environment. Your final geometry that refines and finalizes the solid model using the optimized mesh as a reference. You can really save material and cost when you use shape generator, as you can go and set up your material, your loads, and you will get a refinement of your final geometry, and then you can go utilize it, create your new model, and do all the necessary tests as required. Balancing both quality and throughput. Autodesk Inventor enables engineers to design right the first time, reuse proven components and logic, optimize designs without sacrificing performance by embedding quality into every design stage, and streamline repeatable tasks. Inventor ensures maximum throughput without compromising product integrity. Manufacturers can achieve design excellence and operational efficiency by leveraging Inventor simulation, automation, and reuse capabilities. Team can deliver higher quality products quicker and reliable, meeting modern production demands with confidence. Very important, you need to plan, get the quality, and then streamline your production. What does optimizing involve? You've got your machine capability. Now this refers to the ability of a machine to consistently produce parts within tolerance, meet production demands, and perform efficiently under varying workloads. Optimizing this capability, it is crucial for maximizing your output, reducing downtime, and ensuring part quality. Optimizing machine capability includes also your aligning of designs, manufacturing, and maintenance strategies to get the best possible performance from production equipment. Now, how does Inventor support machine optimization? Autodesk Inventors plays a critical role in optimization at the design stage by enabling engineers to simulate, validate, and refine mechanical systems before anything is built. The benefits of the machine capability optimization is you've got your fewer production errors, it reduces the chance of machine indicated defects, high equipment uptime, avoid overloading or improper usage, consistent quality output, where you stay within tighter tolerances, and increased throughput, where you optimize cycle times and material flow. The key takeaway would basically be to optimize machine capability starts with thinking smarter. By using Autodesk Inventor simulation and validation tools, manufacturers can ensure that their machines are used within the ideal performance range, leading to better quality, longer equipment life, and more equipment and efficient production. Reusing existing data for faster production. We can reuse accelerators in your production, so you do have your faster design cycles, consistency across products, fewer error, and lower costs. And some of Inventor tools that enable design reuse. It's iParts, iAssemblies, Derive tool, iLogic Design Copy, Design Assistant, and even your Content Center. We're going to look at the closing summary of this webinar of driving quality and efficiency. You have your enhanced manufacturing quality, and we're going to have a look at some of the key takeaways. Enhanced manufacturing quality through simulation, tolerance analysis, for instance interference checking and standardization tools. It empowers teams to catch issues early and build it right the first time. Optimized machine and product performance. Tools like your dynamic simulation and stress analysis helps ensure design match machine capabilities, leading to smoother production and longer equipment life. Automation and reuse with features like iLogic, iParts, Model States, and Design Assistant. It enables fast, error-free customization and efficient reuse of validated data. Standardized workflows. Templates, content sensors, and Vault integration enforces consistency across teams and projects. And all of this reduces errors and improve collaboration. So you do have fewer errors and lower costs. The result, you will have a smarter design to production pipeline that boosts product quality, design efficiency, manufacturing throughput, customer satisfaction. The final thought is Autodesk Inventor isn't just a 3D modeling tool. It's a powerful platform for design, automation, data reuse, and quality-driven manufacturing. By leveraging its full capabilities, teams can innovate faster, reduce waste, and remain competitive in an ever-evolving market. Thank you for joining this morning. If you have any questions or would like to reach out to us, please email us at info@mgfx.co.za. You can visit our company page at www.mgfx.co.za. Thank you for watching. Please like and subscribe and follow for more content.